Good morning, class. The past 3 weeks we were busy with beams, where we were calculating reactions, drawing shear force and bending moment diagram for beams. I've given you enough worked example in the section and the tutorial questions. I hope you've attempted them. Yes, some of you have been asking questions, but how I wish that I can get even more questions, because remember, once you start working, doing some work, then you will have questions. Obviously, if you are not doing any work, then you won't have questions. Unfortunately, for a module like structures, you don't wait until you get a test date before you start preparing yourself, because it's a continuation of what we've been doing. So once you do that, then what is going to happen is that you're going to be under pressure when now that time arrives, where now you will be required to do some work, and you're under pressure because the work is accumulating, guys. So we don't want to be piling the work. Okay, fine. But now for the next 3 weeks, remember last 3 weeks we were doing beams. For the next 3 weeks, I want us to focus on trusses. There's in the first week I will show you how to calculate the reactions for a truss, which is not different from the calculation of reactions for a beam, which is the same types of reactions that we were dealing with when we were doing beams. The only difference now is that you are doing the same, you are applying the same concept for a truss. So we're going to be doing that. This video, I don't want to do any calculations. I just want to demonstrate how you're going to approach the question. Then at the end of the video, I will give you it's a worked example in your book. I will give you that worked example, but I want you to attempt it first, and then if there's any questions regarding that, then I will be able to show. I will give you the question, and then I will give you the end results at the end. I'm not going to show you the calculations. I'll just give you the question and the end result. Then how to arrive at that end result, I want you to do it yourself, and please don't look at the end results until you arrive at that stage, because it doesn't help working towards an answer. So instead it's going to destroy us, guys. Let's be honest. Okay, now I hope you've seen a truss before, whether it's timber truss or a steel truss. Imagine you have a truss. It's irrelevant what type of a truss is that. Is it a simple truss? Point loads. I'm going to add another point load there, just for our demonstration to be a bit interesting. I'll just add another point load there. Okay, distances. Let's just use any distances, but before I do that, it's a pin reaction. It's a roller. 3 reactions in total. Not more than 3, because if you have more than 3 reactions, then you are dealing with an indeterminate structure. You don't want to deal with an indeterminate structure. It's 2,5 meters, 2,5 meters, 2,5 meters. The height, 1,2 meters. Let me say 0,8 and 0,8 meters. I'm gonna say this is 50 kilonewtons. This is 55 kilonewtons. I don't have a solution to the problem, guys. I think I must be clear. There is no solution to this problem. As you can see that I'm just coming up with this one. I'm going to say 30 kilonewtons, 35 kilonewtons. As I say, 25 kilonewtons. A, B, C, D, E, F, G, H. Okay, that's my thrust. Vertical, horizontal distances given, and the point loads are acting at the nodes. Unfortunately, when we are dealing with trusses, we're dealing with only point loads. You can't be dealing with uniformly distributed load if you are analyzing a truss. Even if you've got a uniformly distributed load from the roof, you must convert it into point load acting at the nodes. These are the nodes. Again, another information that is crucial, these are pin jointed trusses. Pin jointed trusses meaning you're eliminating any shear forces that might and bending moment diagram that might develop in a truss. When you are dealing with a truss, you don't want to be dealing with shear forces and bending moment. So there won't be any shear forces and bending moment for a truss. You want to deal with pure axial force, tension force, or pure compression force. So the nodes are pinned, meaning they are pinned or hinged. Think about the hinge that you get from the door at home, where whenever you apply a force, then the door will open. If you apply the other side, the door will close. So there are no moments that are developing in those joints. Instead, you just apply the force, then the door will move. Same applies here. The joints are moving, like, I don't know how to demonstrate like this. So they are not tightly joined, but you won't see the movement with a naked eye. You won't see the movement. Okay, fine. So here we're going to be calculating reactions. I hope you can see that. Reactions. We're going to calculate member forces. Member forces being tension force or compression force. Okay. With beams, we calculated reactions, and then after we've calculated reactions, we calculated shear. We calculated and we drew shear force and bending moment diagram. So, are we doing here? Yes, we are going to calculate the reactions. Then after we've calculated our reaction, then we can work out the tension force and the compression forces. We're going to calculate that. Two methods that we're going to use. The first one is called resolution of joints. The second one is method of section. Two methods: resolution of joints and method of section. You can combine them in that very same structure. If you find it easy to calculate that member force using the resolution of joints, then you use the resolution of joint. Then the next member is easy for you to use method of section, then you just use the method of section. So there is no rule saying that if you use resolution of joint for this structure, everything else must be the resolution of joints. No, there is no such. I hope we understand each other. Okay, fine. Now, reactions. Remember, this reaction has only one reaction in this direction. There is no reaction in this direction because it's a roller. It's rolling in this direction. Same concept that we were telling for me. Here we have a reaction in this direction, vertical direction, and we have a reaction in the horizontal reaction. So what is that telling us? It's telling us that these forces that are applied in the horizontal direction must be resisted somewhere. And where is that somewhere? Is there. So if I apply sum of forces in the x direction must be equal to 0. Then what am I saying? I am saying, I must just divide my page into two. I'm saying, please, I am saying AX. Again, I'm going to assume, I can see that AX is going to the right, but I'm going to assume that AX is going to the left. That is my assumption. Then I've got the 55 kilonewtons going to the left. I'm not assuming that it is happening. It's like that. Then I've got this 50 going to the left, and that must give that. Those are the only horizontal reactions I have, and that must give me 0. So because they're all going in the same direction, I can just say plus plus plus. Obviously, if I take these two to that side of the equal sign, then I am going to get a negative answer. I'm not going to work out the answers, guys. You're going to do that yourself. I believe that at least you are university students, you are able to use the concept to apply the concept in a real situation and come up with the solutions. So I'm trying to avoid spoon feeding you. Okay, then you're getting AX up here, and your answer, I'm saying, is going to be negative. So that means AX is going which direction? This direction. It's going to be something kilonewtons going this direction. I'm not going to work it out. I can work it out easy. 110. 55 plus 105. Sorry. 105 kilonewtons going that way. 50 plus 55 is 105. But because if you take it to that side of the equal sign, it becomes negative. What is the negative sign telling you? It's telling you that the assumed direction here you assume this, but the right direction is that one. So I've got my AX, which is 105 kilonewtons. That's my reaction there. I hope you're getting this right. Cool. Now, we've got the first reaction. We still have this reaction and that reaction to deal with, to solve. So, I'm going to take moments about E. Sum of moments at E equal to 0. Can I use sum of verticals here? I can't, because if I use sum of verticals, I will have an equation that has got two unknowns. I'm going to say this is my vertical, this is my vertical. Those are forces applied in the vertical direction. So I'm going to have an equation AY plus EY minus that, these three, then equal to 0. So I have an equation that has two unknowns in it, of which I won't be able to solve for those two unknowns. That's why straight I'm going to sum of E. Now, I'm assuming, that is my assumption, I'm going to assume that my AY is going up. I don't know yet whether it's going up. It's just an assumption. I'm assuming that AY is going up. If I'm getting a positive answer, my assumption is correct. So, AY, I'll show you guys, is AY times, I'm taking moments about E, the distance, the perpendicular, AY is going in this direction, guys. The perpendicular distance is this distance to where I am taking moments, times the distance is 10. And according to my assumption, AY is rotating point E in the clockwise direction. And then I take this 25. The perpendicular distance is that distance to point E, is that distance to point E. There's my line of action for 25, and the perpendicular distance is that one there. And if you look at 25, now you're applying, there's your point E, 25 is applied there, so it's gonna rotate it in the anti-clockwise direction. So 25, I'm gonna write it down, 25 times 7/5, rotating it in the anti-clockwise direction. Same thing for 35. 35 times the distance is 5, anti-clockwise. But there I've got 55. So I've used that 35. The perpendicular distance to that point is that one. And if you look at 35, it's rotating it in there. Now I've got this 55 here. This 55 is applied there. There's point E. So it's pushing, it's rotating also in the anti-clockwise. So it's 55. What is the perpendicular distance from 55? Is that distance. That is the perpendicular distance from 55 to E. So I've got 55, I'm writing it down, times that perpendicular distance is 1,6, and it's rotating it in the anti-clockwise direction. There you go. 55 times 1,6, rotating it in an anti-clockwise direction. So I dealt with this, I dealt with this, I dealt with these two. Now I'm going to deal with these two. Then I've got 30 times 30, line of action for 30 is this one. So the perpendicular distance is that distance to E, because everything is all about E. Our reference point is E. So what is that distance? It's 2,5. And it's rotating it in this direction. Then I've got 50. There's your perpendicular distance. It's 50 times the distance from there is 0,8. Sorry. This must be equal to 0. And 50 is also rotating like this. There you go. AY times 10. That times that times. Then applies the sign convention. Apply your sign convention, whatever signs that you like. If you're saying this is positive, obvious this must be negative, this must be negative, this must be negative, negative, negative. Then you solve for AY, which is equal to, I don't know the answer. I can quickly do it on my calculator. I don't know why I'm doing it. Divide by 10. Then according to this it's 56,55 kilonewtons and it's going up. Why am I saying it's going up? I'm getting a negative answer here. If I take it to that side of the equal sign, it becomes positive, and then I divide by 10. Then it remains 56. I hope that answer is correct. If it's incorrect, guys, please just fix it. Don't give me a call saying no, that answer is incorrect. It's fine. I shouldn't be giving you answers anyway. I shouldn't be giving you answers. I should be showing you the concept, and then you work out the solution yourself. Okay, so you saw how to take moments about E. I took moments about E, and then I got this answer. Whether it's correct or it's incorrect, okay, it doesn't matter. Now, I'm going to take moments about this one now. A. Sum of moments at A is equal to 0. Then, by taking moments at A, that means I'm solving for EY. Okay, let me start here. It's 25 times the distance is 2,5, and look at the line of action for the 25 is there. So it's rotating it in which direction? In the clockwise direction, guys. Then I've got 35 times 5. It's rotating in the clockwise direction. Then I've got 55 times 1,6. Watch the 55 is there, is pushed that direction. I'm taking moments about this. 55 is rotating it in this direction, point A in this direction. Then I've got 30 times the distance from 30 to there is 7,5, and it's rotating in the clockwise direction. Whereas 55 anti-clockwise. I hope you can see this, guys. 55, if you take moments about this, it's just rotating. 35 is just rotating it like this. And then I'm not done. I've done 30. Now I'm going to 50. Then I've got 50 times 0,8. Why am I saying? There's a line of action for 50. It's going there. And if you look at point A, 50 is doing this. It's rotating it in this direction. And the perpendicular distance is that to 50. Any other forces? Yes, I've got EY times 10. EY, I'm assuming is going up. If I'm getting a positive answer, my assumption is correct. If I'm assuming it's going up, then it's going in this direction. Then it's going, I'm assuming it's going up, then it's going in this direction. Then this must be equal to 0. I like to look at this, my unknown, and then I make it positive. So if I make this positive, then this is also positive. Then this is negative because it's not going the same direction as my EY. then this is positive because it's going the same direction as EY. So this one is negative because it's not going the same direction, and so on and so on. Solve that. Minus 25 times 2.5 minus 35 times 5 plus 55 times 1.6 minus 30 times 7,5 plus 50 times 0.8. That gives me an answer that is negative, which is 334,5, which is negative. Take it to that side of the equal sign, it becomes positive. Then you divide by 10, divide by 10. Then you get an answer of EY is equal to 33,45 kilonewton, and my answer is positive. That means my assumption that EY is going up is also correct. So now what do I have now? Sum of forces in the x direction equals to, check is my check here. So I've got 105 going this direction, then I've got 55 going this direction, and then I've got another 50 going this direction. If you say this is positive, this is negative, negative, what are you getting here? 0. So you are almost on the right track. You are correct, but it's not always the case. The fact that you are getting 0 does not mean you're correct. Maybe your mistake, you are consistent with your mistake, okay, but at least it gives hope. Then I go to my sum of forces in the y direction equals to, I've got a vertical reaction of 56,55 going up. I've got another vertical reaction which is EY, that is 33,45 going up. I've got 25, which is the load from the structure, going down. I've got 35 going down, and I've got 30 going down. If I say plus, plus, this must be negative, negative, negative. So 56,55 is going down, plus 33.45 minus 25 minus 35 minus 30. I'm getting 0. Again, if you're getting 0, it gives you hope that whatever that you're doing is correct, but that does not really mean that you are correct. Maybe you are consistent with your mistake. I hope you guys understand how you going to be dealing with reaction when it comes to trusses. Now, I remember I promised you guys, but before you attempt the what, guys, before you attempt the exercise that I'm giving you guys, it's very important that you start off by redoing this very same problem by yourself. Then you can go and attempt the exercise. So it's very suicidal to go straight, you just watch the video and then go straight to the exercise without redoing the example in the video. From the book, this is the example I want you guys to attempt. Don't worry about the directions. You're going to assume your own directions. Sometimes it's not important. It's very important, guys, that you just get the concept right. Make sure that you are just following the concept instead of following the examples in the book. So what I want you to do here, guys, I want you to calculate reactions only. Then the next time, the next video, then I am going to ask you guys to, we're gonna be doing member forces. The assumption will be that you know how to calculate reactions. Because you know how to calculate reactions, then I will come with a problem that has worked out reactions, and then I will just continue, and then we will work out our reactions. There you go, guys, more examples. All I want you to do here, guys, I want you to calculate the reactions only. Don't worry about other stuff. So you've got 4 more problems where you're just going to follow the concept, take moments about this, look at the perpendicular distances, then calculate your reactions. Don't be intimidated by the structure. Some of the problems that you're going to get for the very same problem, they're going to be inclined. You must think about how am I going to approach that problem if I'm getting an angle, a force that is inclined. Again, you know how to deal with that from the beam. You work out the vertical component and the horizontal component of that force. Then you are at this stage now, because you've got the vertical component and the horizontal component there. I hope you enjoyed the video, guys. If you have any problems, you're more than welcome to contact me, whether it's via WhatsApp or Teams or via emails. Thank you very much, guys. I hope you enjoyed the video. Thanks. Bye.